Picture a doctor, right? They're making a critical life-or-death medical diagnosis. Or think about an investor deciding exactly where to place millions of dollars. A pilot navigating through an unexpected, fierce storm. Or even just a business owner forecasting their inventory for the next 6 months. What do all these people actually have in common? Well, none of them know the future. Not perfectly anyway, and yet all of them must decide. Welcome to this explainer. Today we're exploring this totally universal human condition of decision-making. You know, what if intelligence isn't actually about having perfect certainty? What if true intelligence is really about how well we exercise our judgment under uncertainty?
This brings us to what I think is the core question of any serious analytical mind. How do we make good decisions when certainty is impossible? Think about that for a second. We spend so much time chasing perfect data, right? We want perfect foresight, this flawless guarantee of what's going to happen next. But let's be real, life just doesn't offer guarantees. The strongest data science systems and, honestly, the wisest human minds, they don't demand the impossible. Instead, they learn a completely new way to think.
So let's start with part 1, the illusion of certainty. We need to shatter this myth.
Okay, let's dive into this. To live in this new way of thinking, we first have to confront a really comforting myth. Think about all the areas where we constantly try to predict the future. We're talking weather forecasts, sports predictions, massive economic shifts, or just your daily business choices. In all of these domains, demanding perfect foresight is a total trap. I mean, if you wait for absolute certainty before making a move in business, you're going to be way too late. Actually, most massive mistakes begin with exactly this, the arrogant assumption of false certainty. I want you to really absorb this next point, because letting go of that illusion, it's the very first step toward honest thinking. Uncertainty is not a weakness in your model. It's not a flaw in your reasoning. Uncertainty is reality. It's literally the fog on the road ahead. And, once we finally accept that the world just isn't perfectly knowable, we can stop panicking. We can actually start learning how to navigate through that fog.
Moving on to part 2, a language for uncertainty. Let's build a new vocabulary.
So if we can't have perfect certainty, how do we actually deal with a world that's just blurry and messy? Well, we definitely don't do it by throwing heavy, complex math formulas at the wall. We do it by building a new vocabulary. Now, what's really interesting about this slide is this jar of marbles. If you reach in blindly, sure, you don't know for certain what color you're going to pull out, but you aren't completely ignorant either. You can count the colors, you can measure the likelihood, probability isn't magic, and it's definitely not a blind guess. It is structured belief based on observation. It's exactly how we bridge that massive gap between knowing absolutely nothing and knowing everything.
Because, think about it, the real world is almost never perfectly binary. It's so rarely a simple yes or no. So probability gives us a scale. It distributes our belief between 0, meaning impossible, and 1, which is absolutely certain. By living in this space between those two numbers, our analytical systems, and honestly our own minds, can start making graded, honest decisions. We finally stop making arrogant guesses and we start evaluating realistic likelihoods.
I want you to cement this into your mental toolkit right now. Probability, a language for uncertainty. It's really just disciplined humility. It's what allows a machine learning model or a smart data analyst to say, hey, I am 80% confident in this outcome, and here is the 20% room for doubt. And let's be honest, that is a far more trustworthy answer than some fake guarantee.
Which brings us to part 3, the shape behind averages. We're going to look past the surface.
Once we wrap our heads around probability, we actually run into a new danger, and that's relying on a single, clean number to describe a super complex reality. Imagine 2 hospitals. On average, both of these hospitals see 100 emergency patients a day. If you only look at that average, they look completely identical. But Hospital A sees exactly 100 patients every single day. Hospital B, well, they see 50 on Monday and 150 on Tuesday. The average is exactly the same, but the reality on the ground, the staffing stress, the sheer chaos, is wildly different. And this brilliantly illustrates why equal averages constantly hide unequal futures.
So, this introduces us to variance. Variance is simply the risk hidden around the average. It's the spread, the volatility, those extreme highs and extreme lows that a flat, boring average just completely ignores. If you only ever plan for the average, well, variance is exactly what's going to ultimately break your system.
Remember this, averages hide stories. Reality has shape. Distribution is just the mathematical term for that shape.
It tells us not just where the middle is, but how the data breathes, right? How far it stretches out and exactly where those rare, dangerous events live. A mature decision maker never just asks for the average. They always ask to see the distribution.
Okay, part 4, the window into reality. Let's talk about the limits of observation. But even when we do look at the shape of the data, we have to remember one absolutely crucial limitation. We almost never get to see the whole picture. That tiny window we look through, that's called sampling. A sample is just a window into reality. It's a fraction of the total picture. If you survey 100 people, that's a window. It is not the whole world. You know, one of the most common ways really smart people make terrible decisions is by treating a tiny, limited sample as if it represents absolute universal truth. You always have to be asking yourself, who is missing from the sample? What is living right outside the frame of this window?
So the crucial point is knowing how to tell the difference between what actually matters and what doesn't. We have to learn to separate the signal from the noise. A signal? That's a meaningful pattern. It's a true shift in customer behavior or a real underlying medical symptom. Noise is just random movement. It's the daily jitter of the stock market or a weird brief dip in website traffic. If you start reacting to every single piece of noise as if it's a true signal, you will literally exhaust yourself. You'll steer your business straight off a cliff.
Which leads us to part 5, how we fool ourselves. Let's talk about the human weak link.
And this brings us to a somewhat uncomfortable truth. Even with the best data, even with solid probability, things can still go wrong. And the weak link? Well, it usually isn't the math. It's us. The human brain absolutely loves a good, neat narrative. We're wired for it. But reality loves messy evidence. We fall prey to confirmation bias, only seeing the data that conveniently proves we were right all along. We suffer from survivorship bias, jumping to quick conclusions based on tiny, flawed sample errors. We just so desperately crave comfortable stories over cold, hard evidence.
So, to fight these deeply human flaws, we use estimation. Good estimation is really just the art of saying, I don't know, correctly. It's about framing an honest range of possibilities rather than pretending to have perfect foresight. It is confidence without arrogance. When you estimate properly, you're actually giving yourself a built-in margin of safety against your own biases.
And hey, when estimation just isn't enough, we build experiments. An experiment, whether it's an A/B test on a website or a massive clinical trial, is simply a fair comparison. The beauty of it is that it bypasses human bias entirely. It allows reality itself to answer our questions. We don't sit around and guess which web page design is better. We test both, and we let the structured evidence speak for itself.
Finally, part 6, the trust machine, putting it all together.
When you combine probability, a deep understanding of variance, honest estimation, and rigorous experiments, you aren't just doing math anymore. You're actually building a system that can be relied upon. You're building a trust machine. Because true intelligence, whether we're talking about a human analyst or a super advanced AI, it's not about knowing everything. It is about knowing how to reason when everything is not known.
Let's see how this builds into the ultimate formula for decision-making. Trust equals evidence plus context plus limits plus explanation. If you are building an AI, or frankly, just making a pitch to your board of directors, you absolutely need all 4 of these pillars. Show your evidence, provide the context, honestly state your limits and your uncertainty, and explain your reasoning clearly. That, right there, is how you generate real trust.
So, as we wrap up this explainer, I want to leave you with a final thought to carry into your very next big decision. Are you still going to demand perfect certainty from a world that just can't give it to you? Or are you ready to embrace the fog, use evidence responsibly, and finally learn the true language of reality?